All right, hello Charlie. This is a integral substitution video that Charlie, my student, asked me to do. Okay, this is what we will call one of the top drawer integral questions. X squared minus 9. Now, this doesn't look so hard necessarily, but we just can't integrate this using any of our normal methods. And the only way to do it is with a trigonometric substitution. And we begin by observing this. So we know this from our trigonometry. Tan squared equals secant squared minus 1. And inside here, x squared minus 9 feels like secant squared minus 1. So I'm going to choose x equals secant, sorry. And what's going to happen when I substitute this in is it'll look like this, and so I can make it a tan. This. I think that's better. However, because there's a 9 here, I don't just choose secant x, I choose u. Sorry, x is 3 secant u. So what's going to happen is I square it, so that's going to be 9 secant u, and then I'll be able to factor out a 9. So that'll do with that 9. Okay, so let me do that. Wherever I see x, I do 3 secant u. This pen is not so hot. Dx over 9 secant squared u root 9 secant squared u minus 1. Okay, so I squared this one and that one. Oh, minus 9. Now, I have another problem, and that problem is this dx. I need to make it into du. And so we go back here, and if we remember from our trig table, this one should be 3 secant u times tan u. That says secant u times tan u. So my integral now becomes, so dx will be 3 secant u tan u times du. So on the top I get du times 3 secant u times tan u over 9 secant squared u root 9 secant u squared minus 9. Okay. So I'm going to go from here back up here. First thing to say is this secant and one of the secants at the bottom, which is squared, cancel. And this 3 cancels with this 9 to become 3. So I'm going to write brackets du tan u over 3 secant u root 9 secant squared u minus 9. So here I need to substitute out the 9, and it's going to come out of the root sign and become 3. So it'll be du tan u over 9, 3 times 3 is 9, secant u root secant squared u minus 1. This is my trig substitution. That's going to become tan squared over du tan u over 9 secant u root tan squared u. And This is a tan squared on the top and a tan squared on the bottom. And secant will come to the top and become cosine. My 9 will come out, so I get 1 over 9 root cosine u du. Okay. It's complicated looking. But now, it's not complicated looking. This is just a normal cosine. So the integral of cosine is sine. So I have 1 over 9 sine u, and remember plus c. However, we started with x's, and we have to change this back into x. So we go back and say this. X equals secant u. So how do we do this? We need to take sine u and express it in terms of x's. So we need to fiddle up. So we've got to this point 1 over 9 sine u plus c, and we have to do the substitution back into x's, which is a whole other step that we need to think about. So we had x equals sine u, and we now need to think a little bit like our trig skills from high school, in identities and that kind of thing. Oops. X equals secant squared. I'm going to put this into cosines and then use this guy, sine squared x plus cosine squared x equals 1. So I need to make this, x is 1 over cosine u, square both sides, x squared equals 1 over cosine squared u. Now I use this guy, so cosine squared is 1 minus sine squared. So x squared equals 1 over 1 minus sine squared x. So sine squared u. Swap those around. 1 minus sine squared u equals 1 over x squared, or x to the negative 2. So sine squared u is 1 minus x to the negative 2. And so sine u equals root 1 minus x to the negative 2. I look down here, and I have sine u already. So sine u, from this algebra step, I can just plug in there. So the final answer of the integral is 1 over 9 root 1 minus x to the negative 2 c plus c. All right, Shirley, I hope that helps.